G'day. Have you struggled to see the BrewPiLess OLED screen? Don't have your phone handy? Forgot your glasses? Or just want to see where your latest brew's up to? This video tutorial describes how to make a FermWatch to monitor your fermentation in the shed, beside the bed, wherever your local network extends. The FermWatch project was very much inspired by the Slammy's iSpindel hub project, where the iSpindel readout was displayed. Initially, I just wanted a bigger screen for my BrewPiLess, and then I developed the display to show iSpindel data from Brewfather, plus some derived functions. It's important to recognize that I am a brewer. I am not a coder programmer. It has taken me 4 months to reach this stage. It works with my hardware as described. This tutorial covers the system, how I went about the software, how to actually set it up to use it, and then the FermWatch configuration. My choices for the system configuration were very much driven by the types of failures that I've experienced over 4 years of using BrewPiLess and 3 years of iSpindel. I defined that internet failures when the connection to the internet fails, but the local Wi-Fi network is still available. So ultimately, I've done this on the basis that I like the diversity of having 2 separate streams of data, with some fermentation data logged with Brewfather under BrewPiLess connectivity failure rather than none. The normal mode of operation is that BrewPiLess sends to Brewfather and iSpindel does the same. And Brewfather handles all the data logging and display, etc. For FermWatch, BrewPiLess has the ability to send Mqtt data, and that's received by FermWatch through its broker. FermWatch also does a 2-shot process of accessing the Brewfather API. The first request gets the fermentation batch ID, recipe name, measured OG, and estimated FG. And the second request uses the batch ID to get the latest readings from the batch, so that there is an alternating cycle between BrewPiLess data and Brewfather data. So FermWatch displays BrewPiLess information very similar to that available on the OLED display, albeit in color. The Brewfather data is also displayed, and most of that is related to the iSpindel. There are some derived functions to display percentage ABV, and the tax tables that I've used in the software, there's a link to the source of that on GitHub. The initial setup is through using WiFiManager, and there are a series of options where you can select between Plato and SG, Fahrenheit and Celsius, and the experimental function related to temperature correction. A lot of what's displayed is very dependent on the information that you put in. And one of the key areas around that is the accuracy of the specific gravity measurement. There are quite a few sources of error, particularly in not reading to the bottom of the meniscus, and the other ones as described. There's also errors that relate to the iSpindel. does require that the iSpindel is correctly calibrated. You tend to get crows on the iSpindel that could affect the readings. The one possible exception is that if BrewPiLess is configured to use the brew and calibrate method, then perhaps you wouldn't need any temperature offset. As in all things, the temperature correction that I've implemented is an approximation. It's very much based on the assumption that the iSpindel was calibrated at 20 degrees centigrade. I've used interpolated values that come from Wheeler's Brew Your Own British Real Ale, and I do think that for practical brewers it could be a useful setting to use. As I mentioned, you do tend to get a fair bit of crud on the cap of the iSpindel. And one of the other things to remember, that because you can adjust the gravity reading in Brewfather, this will also reflect in the numbers on FermWatch. As with all things, it's good to set a few boundaries. So FermWatch has been designed to work with a specific set of hardware. It only monitors one fermenting batch at a time. There's no logging, there's no control. It's essentially a display device. If you put incorrect information in, you're going to get incorrect information out, as in garbage in, garbage out. The Brewfather API states that it's experimental and may change. This could break the Brewfather linkage. FermWatch works within the range of your local Wi-Fi network, and the number of decimal places is not representative of the accuracy of the data. It is more to display incremental change. The parts list, the bill of materials, is as shown. The cost in early 2022 was around 35 to 40 Australian dollars. You will need some tools: soldering iron, solder, files, Stanley knife, drill, and some bits. The wiring is fairly straightforward. The list of connections are shown. I use DuPont connectors as they're easy to manage. For the assembly into the food container, I marked out the cutter and the lid to suit the TFT display. I drilled a series of 3mm holes all the way around to make the cutout, punched it through, and then used the file and the Stanley knife to trim the hole to suit the TFT display. Once it was a nice snug fit, I drilled for the mounting holes and attached using the threads. I soldered the pins to the 8266 D1 Mini, soldered the flying leads to the push button, drilled a hole and fitted that in, put the cable gland in and put the USB cable in. Please make sure your USB cable is suitable for data transfer and not just power. Then it was connected up through the DuPont connectors and the system was ready to be flashed. Now, if your eyes glaze over with the difficulties around software, you probably want to skip this bit, but for those that are interested, I used VS Code running with Windows 10. I used some specific versions for FermWatch, which I found to work. Some didn't. and the details are there. As far as I can, the code has been documented and has a fair few debugging print statements for the serial monitor that can be turned off if not required. It didn't seem to make a huge difference to the final program size or speed as far as I can tell. The screen cycle times were derived by trial and error. There's a limit of 150 requests per hour on the Brewfather API, and the iSpindel is set to report every 15 minutes. So I chose a 3-minute Brewfather setting, and for BrewPiLess I chose between 75 and 115 seconds to give a decent rotation on the screen. If this doesn't work for you, try resetting FermWatch and change the Brewfather interval and or change the settings in BrewPiLess. Nearly everything I did required extensive research on the web and then trial and error to work out how to get it to compile and to work as expected. One of the things by rotating the screen is that X becomes Y and vice versa. This diagram are neat versions of my screen designs, mainly for my reference. If you notice the orange dots, where orange dots are displayed, it means that the temperature correction settings are on. Having a colorful TFT display rather than the OLED screen means you can do some different things. So instead of having text-based status, it's color-coded. So the border of both of the screens indicate BrewPiLess status plus some housekeeping. Gray is an intermediate state as well as idle. Gold means that it's not yet fully initialized. Purple for error message. The screen shown has the BrewPiLess data and is idling. There is no derived apparent attenuation or ABV as the present gravity has not yet been updated from the Brewfather API. Now, it's important that you have a subscription to Brewfather for this to work, because if you don't have one, it ain't going to work. Now, I've been using Brewfather for a few years now, mainly for recipe design. And as far as APIs are concerned, 6 months ago, I wouldn't have had a clue what an API was. But I had to play with the OpenWeather API, and I learned a bit about screen presentation and getting the data out. The Brewfather API was a big step up, but it offered the benefits of exposing the batch and recipe details, and in FermWatch's instance, the fermentation status. As you can see, there are a couple of things you need to do. You need to have your user ID and your API key, and you need to put a colon between the two. So once you've got your combined user ID and API key, you need to base encode it. This is an important step that I totally missed the significance of when reading the Brewfather documentation. The links are all below. To state the obvious, FermWatch will not work unless Brewfather is at fermenting status and the iSpindel is attached to be able to generate the readings. So you do need to attach it. And please note that the Brewfather iSpindel screen will work without BrewPiLess being connected. Now, I strongly advise that you test your user ID, API key, and accessing the information on Brewfather using Postman. You don't have to use Postman. You could just jump to the next section. However, it does prove that your authorization key works and you've configured Brewfather correctly. So once you've entered your authorization details into Postman, then you can paste in the URL as shown and hit send. And with a bit of luck, you will get a display at the bottom of the screen that will include the batch ID plus some other data. Here you can see it in a little bit more detail. You need the batch ID to access the iSpindel fermentation data, and where the boxes are shown, that's information that is used within FermWatch. So the next step is to insert your batch ID into the URL as shown to get the latest data and hit send. This now returns the latest information. Bear in mind that this is on a 15-minute cycle, so it's not going to change too often. Now we can look at the data in a bit more detail. The order of the data may vary. It doesn't seem to affect FermWatch's operation. So the temperature is in Celsius, SG is the present gravity, ID is the name of the iSpindel, pressure is in PSI. It's either via a manual entry in Brewfather, or if you have BrewPiLess configured to measure the pressure, it would be BrewPiLess via Brewfather. Battery is battery, time is in hieroglyphics, and the tilt angle is in degrees. The next step is to set up BrewPiLess, and you go to the logs Mqtt settings and look for the broker settings. So you put in the IP address that you tend to use for FermWatch. You put in 1883. Don't ask me why, just do it. I didn't bother with name and password. Put in your cycle time. This one was set for 90. Put in BrewPiLess BPL and select whole as JSON. JSONs are interesting things that I didn't know about before, but now I do a bit. Don't forget to select it and don't forget to submit. So now what we need to do is flash the D1 Mini. So you download the FermWatch bin file from GitHub, with the links will be below. I use the Node MCU Pi Flasher version 4 with Windows 10. I'm sure there would be other ones that would be suitable, but I've not tested them. Hopefully you've managed to flash FermWatch OK and press reset to launch the WiFiManager. As it says on the screen, you should get a FermWatch AP appear, and enter FermWatch, all lowercase, as the password to be able to log into the access point. Again, to state what may be obvious, you do need to have your device near the D1 Mini FermWatch to be able to see the access point. So you put in your network details, and I recommend using a static IP, as BrewPiLess needs to push data to FermWatch, and you don't want the FermWatch IP address getting reassigned by your router. So after setting your network up, there's some other information to be entered. You need to enter your authorization key. And a tip here is that if you copy that information to the clipboard ready to paste in, it makes life a lot easier. Then there's the ability to set your time zone. Now, Google is your friend here. I'm in Australia, so I've set it up obviously for Australian time. And then there's the Brewfather update time, which, as I mentioned before, I've set for 3 minutes. Then there are the options. If you want to set Plato, if you want to do the temperature adjustment, you hit save, and hopefully all will be well. The most common problem that I have found while testing was that the Brewfather authorization key didn't get entered properly or become corrupted in some form. My solution for that was resetting the 8266 and re-entering the key, which has worked for me. On occasions, it might be due to power surges or something, the system resets itself, or it gets part way through the waiting for the batch screen and resets. So just do it again, and once it's established, it seems to be okay. Just a note about what I've perpetrated for manual readings. Brewfather, you can add in a manual reading, and let's say you put in a manual pressure number. Then FermWatch displays manual instead of iSpindel name until the next cyclic update, just so that you know what's going on. The links are below to my GitHub for the code, and I hope that you find FermWatch useful. When I'm not gadgeting, I write books on recreating historic beers. And if you are interested in that, all the links are below. Thanks for watching. Cheers.